Okay. So easy start to the morning, less talking, more doing, right? Which, I'm always a fan of. In my world, just to say this, is like, I love doing these classes when they're extended like this, because it's a little bit more like interactive. Like we can do like the exam crams and sneak everything in. Um, has a Amazon authorized instructor, part of my agreement with them is that we, can't really change any content, right? We're not allowed to do that. But what's interesting is that sometimes we have people who will go for like a longer, even longer version of the class. And what we'll do is we'll just throw in labs in between every single section, every single time. I actually have a meeting with training and certification with Amazon next week. And I'm like, I don't know if you know, but adults, especially in the IT industry, really like to do the things they learn. So talking to them a little bit more about what is it, pedagogy, right? Or is it andragogy? Andragogy, because pedagogy is kids, right? Like, about like adults really like to be hands-on. So good thing about this morning is that we're going to launch right into hands-on, because we talked about serverless yesterday. We talked about SNS and SQS. So, we had, these ancillary like application, abstraction layers that you could stick in, to serverless. And then we touched briefly on step functions and about application gateway, but it was all super high level. So today we're going to finish up the lab for serverless. We're going to do some edge services, some backup and recovery. And then what I'm going to do is we're going to spend some time doing a little bit of exam cram and some training. And I'm going to talk about the exam in detail. And I'm going to go over your student portal that you have access to, so you know exactly what kind of awesome things are in there. They're going to help you further your expertise, even if you don't want the certification. If you want the certification, those same steps are going to help you with the certification as well. So, and then, just to say this is that you have at least email access to me after this. So don't feel like that once we're done, if you have a question about the certification or whatnot, I'm available to you. I still talk to people from, 2016 who, took a class and are like, hey, what about this, this, and this? So, please know that, you will have support after this if you want it. Okay. And I have no idea what David's plans are beyond this. I'm sure he's got nefarious training and insidious cloud plans for you to drive his ideas around cloud and whatnot deeper into the group. So
yeah, we have 48 hours from Friday to take the test.
Really?
Come on. No, we're gonna get together. We're gonna figure out what the plan is, what makes sense, and then something that is reasonable and viable.
Okay.
We want to continue the training path for sure.
And David, I'm going to talk, and just for everybody also, is I'm going to talk about what our normal recommendation about your certification path would be. So that should set expectations if you want to follow it. Obviously, you can do whatever makes sense to you, your company. But I will talk about our 8-week plan that we typically follow, that we recommend people do while they're working. If you all weren't working, we would follow a much more aggressive path. But just know I'll give you a suggested path, and then David will modify it however the group sees fit from there. Okay. All right. So that's what we're doing today. Reminder, we are going to be in Skill Builder, so please make sure that you've logged into Skill Builder. If you haven't done that, you're going to be spending time that you probably want to spend on the lab figuring that out. So try to do that before lunch if you can. Meanwhile, I hope you go here. I want you to go into Lab 5 inside of Quick Labs, with, again, webh.quicklabs, where we've been all week, and then go ahead and click on Start Lab. Here's what you're going to end up doing inside this lab is that all the stuff that we talked about yesterday, the SNS stuff, the SQS stuff, setting S3 event triggers, so you can actually trigger a Lambda function. You're going to set that up, and you're going to configure some Lambda functions, right? And so what's going to happen is that you're going to like process a file, and it's going to kick off some Lambda functions, and it's going to send a notification, and it's going to send post a message in the SQS queue. 2 caveats. 1, patience is going to be your friend here, because like the email sometimes takes forever to get through the system. And I don't know if it's the corporate systems or if it's the SNS itself. So I'm not pointing a finger at anything, but sometimes it takes a while for these email messages to get through the systems. So, and you can see, by the way, in SNS where it's been sent, but you don't really know how it's been navigated from there. So 1, patience is going to be your friend. 2, the other thing is that again, if you build the SQS and SNS objects in Oregon because your console accidentally switched you to Oregon, and then you go build the S3 bucket in Virginia, it's not going to work. So just make sure that all the objects are in the region in question. Now, I say that you can actually make it so that, for example, you can talk across regions to other services, but there's a lot of steps you're going to do for that, and that's not part of the lab. So we're not doing a cross region architecture. We are in a single region. So make sure it says US East in your browser. Just check on it on occasion. It seems like that's stabilized a whole lot because I don't think any of you have said anything about it switching regions on you. So I hope you won't run into that. But again, just a caveat that is frequently popped up for people. And then the only other thing to mention is that after you validate all the files have been processed or whatnot, there's a couple of challenge tasks. And the first one is the lifecycle rules for S3, so that like you can like roll files to lower tiers of storage, like colder tiers of storage. And then you can add an SNS email notification to the existing topic, to the SNS topic that you've created earlier, like in step 1. Okay. So otherwise, stop talking. You're free to take a run at this lab. This typically takes about 45 minutes. So, I'll check in around the 45-minute time frame just to see how everyone's doing. And otherwise, just go forth and conquer. Okay. All right. Very loud. Okay, so here we are. Let's talk about edge services. So first, obviously, we have our check-in question. So now this, I feel like might be actually be a relevant question for you all, is that what percent, like, would you say that most of your projects require ultra low latency, or is most of your stuff just kind of like normal? Just kind of curious.
The mix of both.
Just to say this, most companies I work for do not require ultra low latency. Like Honeywell, for example, sometimes they had high priority, like very important, especially the military contracts that required ultra low latency. I imagine some aspects of your business are probably high frequency, right? And competitive edge right there. So, I don't know exactly what your business does, but so you do actually have a mix. So some of your projects actually do require ultra low latency. What is ultra low? Like, what is that defined as? Is that microsecond, or is it just really single digit millisecond?
Quantum. We're really good.
Really? Is that a thing? So you guys are using quantum entanglement in order
No.
to actually get real Ansible level? That's a real thing, right? That like if you take a cesium atom and you split it and you have it in one direction, if you rotate the other one instantaneously faster than the speed of light rotates in another direction. They're actually using that to actually create communication devices.
No, Gene's working on that right now.
Interesting. So millisecond requirements. Thank you, Rakesh. Rakesh. And then some internal tools that don't matter. Okay, fair enough. That's going to be really weird, honestly, when we get, I think in science fiction that was called an Ansible, right? I don't know who came up with the concept, but it was like faster than light communication. That's going to be strange. So yeah, most companies I work for have, single digit millisecond. It'd be their lowest requirement. Most of the time, a lot of the internal tools don't even have an SLA on them. Like if it goes down, it's a problem. And if it performs slowly, it's a problem. But the definitions of slow and none of that's really defined. Very rarely do I see microsecond requirements. Okay. That's a good reminder, actually. Let's fix that. All right, let's pre-warm this lab so we don't have to wait. Okay, good. Okay, so the call to action here is that there's a bunch of, it's basically help desk support people and people answering questions, providing customer service and customer support, and they're globally distributed. They have a mobile app that does a variety of different things. Right now, everything's centralized in California. However, the farther they are from California, the more latency they see. So They want to be able to enable content delivery networks, like, a la Akamai, Cloudflare, Fastly, that kind of thing. They also want to be able to protect against distributed denial of service attacks. And all of this is outside of the core. So this is outside VPC stuff that we're talking about here. This is not core items. This isn't even really regional data center items. Although I say that, some of this touches on the hidden regional data centers that are inside AWS, but this is outside of VPC items that we're talking about. Now, in a completely kind of edge serverless architecture, if you're going a little crazy, right? Notice you've got DNS, which is already globally distributed, and DNS is the only service that I'm aware of that AWS has 100% uptime SLA on. Everything else, is a variety of nines. Now I chuckle because when I found that out, like, I want to say late last year, that they were doing that, they immediately had a DNS outage, which honestly was their first outage in quite a while. But then they had a series of outages. Other than that, their track record, it had been a long time actually since they had an outage of any type. And they are very rare and few and far and in between here. Now, micro outages where like an availability zone goes down, those probably happen, once a quarter. That's not infrequent, but they warn you that that's going to happen, which is why they want you to follow best practices. But global outages are very rare with AWS, and I think even in some cases even more rare than with Google. Although last year was a banner year for all three hyperscale cloud providers to have a series of outages, so AWS wasn't alone. Note here that once you get past DNS, you might actually want to do either some interception and caching, which is what CloudFront does. CloudFront does basically caching. And then the global accelerator does basically like traffic distribution. So it redirects traffic towards the nearest region. So it uses, by the way, this like globally available anycast address, and you send traffic to that address, and then it redirects it to the appropriate region, which then again there could be intercepted by a load balancer, like a local, like an ELB. And you can combine these things. So you could have a routing policy, and on the DNS side, we talked about the routing policies like geofencing and whatnot, and you could combine that with global accelerator in order to like get some granular control over how traffic is distributed globally in your enterprise. And then note that once you get past these objects, there's a variety of security tools that can actually be thrown in there. And there's actually one that's not listed because we usually don't talk about it unless it's at the professional level. But there's actually another firewall in AWS, in addition to the security groups, in addition to the NACLs, outside of your VPC environment. And you can put it right inside if you want to. You can also throw out a network firewall. So just know that you can actually throw out what's called a network firewall, which is another service inside AWS. But Shield and WAF, so WAF is just a web application firewall. That's just literally a filter that will either allow or deny traffic to come in on, web, HTTP and HTTPS, right? You can filter that traffic. You can filter it for like cross-site scripting, SQL injection attacks, like anything that you can regex, anything you can do regular expressions for, you can put a rule in for the WAF. Now, by default, all accounts have denial of service protection. It's called Shield Standard. As you can imagine, AWS is constantly under attack, because imagine how valuable it would be if a single hacker could get in and get somebody's customer data or whatever. So they have a Shield Standard, which is turned on by default for everybody. You can actually pay for what's called Shield Advanced if you want to. And that's a year commitment. And I think it costs $18,000, again, numbers. And you get access to a shared team. And so they will proactively write rules into your WAF that will prevent attacks that you can then review and associate if you want to. So just know that they offer basically a distributed denial of service package. You get standard by default, but if you want more advanced response and you want to interact with the security team more strongly, you can pay for Shield Advanced. And then last in this diagram is Outpost, which is really just you running AWS's hardware in your data center. So you set up a time for it to be scheduled. They give you the specifications. You provide networking, cooling, power, that kind of thing. and then they set up the equipment and then make sure that it can talk to AWS, and it looks like it's part of your infrastructure. You can also run it disconnected if you want to. So it doesn't run everything. Outpost will run things like RDS, S3, EKS, ECS, EC2. So it runs like core stuff, core services. So for this module, the questions that we're looking to like answer with that variety of services that I just talked about was like, how can we improve the performance, the user experience for internet applications? How can we reduce latency? How can we secure and protect the, AWS at a variety of different layers? What if I need a static IP address globally, like something bigger than the load balancers? And can you run AWS workloads using their services and their tools in your data center because you require that? How does that work? So we're going to talk briefly about edge fundamentals, and then we're going to talk about some of these specific services that make sense here. So, the edge is defined that it has basically anything that's outside of core, meaning anything that's outside of your core data center is usually considered the edge, right? So all of your remote offices, all your mobile trucks and devices, if you have IoT devices that are associated with different kind of vehicles like planes or ships or whatever, that's all considered the edge. That's all outside your data center. And that can include, by the way, like employees' homes, especially during the pandemic. Now, AWS has a number of ways they're going to bring their services closer to you. We talked a little bit about local zones when we talked about infrastructure. Those are just single AZs that are outside of the region, right? That was the whole long list of like Los Angeles, Denver, Austin, that kind of thing, Atlanta. And then AWS also has outside of region locations that provide basically cell services, so 5G. I wish there was more of that, actually. I have not personally used any of the wavelength locations, but I know they're there. There's not a single class on that either. So I have yet to work for a company that needed it. Outposts I have used along with the other hyperscale cloud providers. They all have their own version of this. And it works really well when it's connected to the cloud. It's not as easy to use when it's disconnected. So a whole different set of processes when you want to host it disconnected from the internet. So the edge locations is just that scattering of servers. Remember I said there's either a server or a rack of servers that was just scattered wherever there was a major ISP in the world. So note that, there's far more edge locations than there are like regions. So there's like 30 regions. There's like 300 edge locations. Notice that some of the edge locations exist inside the regions. There are regional caches that exist inside of each of the region, like data centers. This use case is one that we have talked about before, where a customer is trying to get a video file and the source file is located in Brazil. DNS would intercept that request, redirect them to the closest physical box that Amazon has. That box over Amazon's high-speed backbone would go back and grab the source file and then present it to the user. And then when the second or third or fourth user in that area asks for that same file, as long as the file hadn't expired, which you get to control, it would not go back to source. It would just run it out of cache, which is the very definition of a content delivery network, right? So Amazon has CloudFront, which is a content delivery network. The cool thing about using CloudFront is that Amazon will not charge you for any data that leaves the data center. So one thing you probably want to know about billing is that Amazon will charge you every time you pull data out of Amazon. You can put all the data you want for free in Amazon. If you pull it out, they'll charge you like fractions of a penny per gigabyte. I once had a guy over Christmas. We were using Akamai. We weren't using CloudFront. He changed a JPEG from like 120K to like 100K. That is a 20K difference. Like, and honestly, for most of us, who cares? Now, what I didn't know is that that file was downloaded, I want to say it was 8 billion times a month off of Akamai, which means it was pulled off of AWS, because every once in a while that file would expire and I have to go back and pull it out. We saved like $20,000 a month or something, or $30,000 a month just from that 20K file change, because we were using another content delivery network. So I'm not saying you shouldn't use like Cloudflare, Fastly, or the other competitors. I just want to say this is that you're going to get huge benefits if you do actually use CloudFront, and it is very comparable in terms of features. Obviously, it doesn't have every bell and whistle that perhaps another provider might have. So since CloudFront is so tightly integrated in, not only will you save on billing, but it will do a lot of native integration for you without you having to figure out what those integrations look like. So CloudFront does leverage the 300 plus points of presence that are, you know, the edge locations that are available all over the world. And you can stage CloudFront to say, look, I want you to cache into the regional data center, and that one expires in 6 months. And then you could have other caches go to that cache in order to refresh. In other words, you can do what's called staged origins, right? Where you can actually like push your origins out so that your source servers are hardly ever hit at all unless there's an update. Now, if you do this, by the way, if you use any kind of content delivery network, make sure that you are versioning your assets, because it is the best way to not only troubleshoot, but also to make sure that you do not have to bust cache. What do I mean by bust cache? Bust cache is when you go out and you actually force the entire network to drop the current file because you've got a new version of it. Almost all the CDNs are going to charge you for that. So instead of doing that, just make sure you version your JPEGs and you version your HTML and you version your, client side JavaScript. Now, if you are not using, so let's say, for example, you're serving your images from like a traditional web server, right? And you might serve an image named, sunset photo, which is why I think it's got that little sunset on there, right? So your users can easily navigate to the web page and they can see the image, right? But they don't really realize that their request was actually routed, from one network to another, right? Until the image was found. With CloudFront, what happens is that you just have now an interception cache, and the users are going to actually talk to the cache, and they're not really going to talk to the backend web server. As you can imagine, this takes a tremendous amount of load off of the web server on the back end. So you can actually run smaller web servers or have the servers focus more on dynamic content and just let the cache handle all of the static content. So, and not only that, a lot of people will put the static content in S3 and leave the dynamic content on the web servers and use CloudFront to scale the S3 content if it's hit pretty heavily, right? So you decrease the latency, plus you add another abstraction layer, which can also increase security, because there's 300 plus CloudFront servers. You might only have 10 web servers. So if someone tries to DDoS you based on those requests alone, it's not going to happen. And Amazon will throw up more virtual machines in order to prevent that from happening as well. So it's an automated response. So CloudFront is really good for static content. It's also decent for dynamic content. It'll also cache APIs. You could turn on SSL. You can do all kinds of interception. For example, you can make it so that you can change what you do when you receive it. You can change what you do when you send it back to the origin. You can change what you do with the file when it comes back from origin, and you can change it before you send it back to the client. So there's all kinds of really cool kind of transformations you can do to these files, like security checks, strip things that from, different pieces of information. There's lots of cool things you can do to filter out with CloudFront. Now, CloudFront's setup is actually pretty simple. First, you choose your source. What's the origin? Is it going to be another web server? Are you going to run it through a load balancer? And by the way, it can be a server that's in your data center. And then you create the CloudFront distribution and you're going to define the path. Are you going to force SSL TLS? Are you going to use signed cookies? Like, you know, how are you going to approach this? What's the time to live for the content? When's it going to expire? Right. And then when you create the distribution, it's going to give you a URL, by the way. And if you want, you can associate that URL with a custom domain name. You can put a WAF in front of it. You can put a Lambda function around it. You can do all kinds of things. Very flexible. CloudFront's been around for a while too, so it's a really stable product. Here, by the way, CloudFront, you know, you can either do a custom origin like an on-premise server. You can use the load balancer. You can use S3. You can control the behaviors, right? You can do all kinds of regex pattern matching. By the way, if you don't ever want it to cache, you just want it to use Amazon's backbone to transfer all your assets, you just set the time to live to 0, which means that it is always expired, right? And then what it will do is it'll just act as an intercept and redirect all the traffic to Amazon's backbone, right? By the way, you can set primary and secondary origins. So if one origin fails, it fails over to the second origin. So you can actually configure it to do some failover, much like DNS. Very useful when you have a multi-region setup. Here, by the way, they're talking about, you know, JPEGs, but then they also have HTML with a TTL of 0, which means that that's automatically expired. So you might see vast performance gains if you cache dynamic content. Most of the time, you're going to see mild performance gains. CloudFront, by the way, can also geofence. So you can also block specific users from accessing it, right? You can actually use the native one. CloudFront will actually also integrate with third-party geolocation services if you want more granularity. I think CloudFront will only go down to the county, not the county, the state level. No, not the state level, the country level. It'll go down to the country level. Beyond that, if you want more granularity than just say like, I want, you know, different provinces in France, you're going to need to use a third party for that. If you want to do geofencing there. Geofencing is also called geo-blocking or geo-restriction. So other words for it. But that's CloudFront. They were like A Cloud Guru for years, by the way, ran their website off of an S3 bucket with CloudFront in front of it. And whenever they needed anything kind of dynamic, because S3 can only host static content, they would do client-side JavaScript, which would then call an API gateway, which called the Lambda function, which then did the dynamic execution. So for years, A Cloud Guru ran their entire company website off of an S3 bucket with no servers. So I think that since that time, they've switched away from that. But I think only because the volume has gotten so large. So in the pair, if you remember the original diagram that we were talking about at the beginning, you know, we just talked about CloudFront. We've already talked about Route 53, so that was like one of our last discussions. Now we're going to talk about Global Accelerator. So Global Accelerator is interesting because most people are not aware that Global Accelerator exists. So without Global Accelerator, right, you might have to go, you don't really have a whole lot of control over the different paths that you would take. But if you want to run like different paths you would take to get to your data center, if you want to run a multi-region setup, because speed is of the utmost importance and you need higher levels of availability and performance, and you want to run something multi-region, you know, you need some kind of global load balancer to do that. And so this is where Global Accelerator comes in. Global Accelerator will then like direct you to the closest nearest location based on, you know, what your architecture looks like. So for example, here's a Global Accelerator endpoint, and it's got a single IP address. Now, Amazon typically has the 54 range when it comes to IPv4. They do have others. Excuse me. And so notice that the anycast address in green will redirect to the closest data center if it's up, no matter where the user is in the world. So, if they're obviously in Europe, they're going to go to Europe, right? But this single IP address acts as a single entry point into any of these data centers, no matter where they are in the world. So they're directed to the closest edge location and or data center, depending on what you're routing for, right? So this, by the way, goes over AWS's global network, not the internet. So they always are routed through the optimum path. So instead of having to go through tier 1, tier 2, tier 3, tier 4, get to AWS, then hop to your data center, they might go through 1 or 2 tiers, hit the anycast IP address, and then you're on AWS's backbone. Your hops are reduced. You've now got the fastest, most latent connection you can get across the world to get to that data center. So it reduces the number of hops. Now, if one of the data centers goes down, but we've got people in Singapore who need to get access to the system, it'll redirect them to the next available system, right? So if one of the regions goes down, it's going to direct it to the next available region. So this allows you to control what failover looks like. You can also configure weight. So you can say, look, EU Central 1 has more horsepower than the other 2 data centers. So I want, 60% of the traffic to go over there. So there are some limitations with Global Accelerator, but they're mainly around like direct connect and the reassembly of IP fragments. So nothing that most people really deal with. These 2 products, by the way, are very different. CloudFront is a CDN, it's a content delivery network. Global Accelerator is basically a layer 4, right, proxy. It's a traffic manager. That's it. So CloudFront is only for web applications. Global Accelerator is, for layer 4, for TCP or UDP. So very different. So moving past content caching and past global like load balancers, let's talk about distributed denial of service. So there's a couple of tools, right? Because what we're talking about here is where someone has a huge bot net of infected computers, and they can basically simulate user traffic, and they're either trying to knock you offline or they're trying to open half a handshake, as part of the TCP IP 3-way handshake. They're trying to do like a send flood, request where they're just flooding you, right? With sends. There's a couple of that's an interesting way of saying that. And so AWS has a couple of tools that will prevent you at different layers, right? So for example, for the infrastructure layer, the base layer, they use Shield, and everybody has this by default. For layers above this, right, where you're not doing UDP reflection attacks, and you're having to deal with what looks like malicious traffic, either because they're abusing certificates or they're trying to do SQL injection or whatnot, you're talking then about using a WAF at that point in time. So Shield is in line. It's always active on every account. If you want to up it to advanced, you can. But a WAF is what you're going to use to defend against the higher version, like layers of attacks, layer 7, layer 6. Now, the WAF is a cloud native like application firewall. So you create these access control lists, these web access control lists, and you associate them with a different like type of traffic. So you can monitor this in real time, and the AWS Shield team will also, if you sign up for advanced, will also monitor your WAF in real time as well. So, and you can dump data out in a variety of different formats, right? Data firehose, S3. There's a bunch of ways to export data out. In terms of access control, you're going to have an access control list that has a series of rules in it. Each rule is going to contain a statement that says, this is how I want you to handle traffic that matches this pattern. These rules are then put into groups, right? So these rule statements are, make up these rules. These rules are put into groups. The groups are associated with the ACL. So you get a lot of granular control. You can actually grab well-known rules from like governing bodies, right? Also, like, there's entities out there that will publish like rule sets that are respected in the security community. AWS has their own rule sets. They'll take rule sets for malicious known bad actors. They constantly update them, and you'll subscribe to those rules, and they will constantly update them to block, bad known attackers. Obviously, this is with vendors that you have a relationship with. You wouldn't just do this blindly, right? And of course, you can create your own custom rules as well. The rule statement, right, basically tells the WAF how you want it to look at these requests, and if what kind of criteria to look for, what should it match. They can be simple, they can be complex. I mean, when we get into regex, by the way, we're getting into a level of like, dark magic around pattern matching. So really, the only limit is, do you know how to write that in regex? That's it, right? And then in addition to Shield, which acts as a distributed denial of service protection layer, in addition to WAF, which acts as an application firewall for web applications only, you can't actually manage all this with what's called a firewall manager. It does require your accounts to all be in an organization. And I want you to know this is the only mention in the entire course of the AWS network firewall in the lower right-hand side. Now, at the professional level, we talk about the network firewall a little deeper. So when you take advanced architecting, you'll see it there. But just know that it is there. It is a full-fledged network firewall. It can do DPI. And anyway, just something to know if you're looking for an extra layer of firewall defense. Now, notice the firewall manager, by the way, can push rules to security groups, to the WAF. It can talk to the Shield team. And if you have a network firewall in play, right, it will push the network firewall configuration as well. This does require, by the way, I think organizations, and you have to have AWS config active. Config, by the way, is just a configuration tracker, is not a configuration manager. So firewall manager is useful when you have a lot of accounts, a lot of firewalls active, a lot of WAFs active, and you need to be able to create a minimum base standard that's pushed across all these devices. So, if you want to get visibility, transparency into all the threats, you can do that as well. Here is a typical, what they consider DDoS resilient. Notice it didn't say DDoS immune, right? Notice that Shield's over here on the left-hand side. We got the firewall manager, the WAF in play. And what's happening is that the filtering is happening at the firewall and the WAF level, depending on what kind of traffic we're talking about. And then CloudFront is also in play to do some filtering if necessary. And so this puts so many abstraction layers in front of your core EC2 instances that it's going to be really hard for them to overpower your backend systems, because they've got to overpower the 2 or 3 layers in front of it first. Okay. And then last but not least is Outposts. And, let's say that someone says, look, we can't run your services in your data center. We have to run your but we can run your services in our data center, just because the data has to reside in our physical location. So we can run RDS and we can use EC2, but we can't do it in your data center. We can only do it in our data centers. Awesome. You can get Outposts for that if you wanted to. Now, without Outposts, it's like, well, these apps need to stay local, so we can't go on cloud. With Outposts, what ends up happening is that it's part of the AWS cloud, but it's on your data center, your premises, right? So AWS is going to schedule a time with you. They're going to give you a checklist, right? You're going to meet certain requirements, including weight and all that stuff. There's an Outpost rack, and they're going to establish, power, check the cooling, and then make sure network connectivity is done before they will leave the premise. Here are some things that you can run. So notice RDS and Elasticache is there. ECS and EKS are there. You can run ALBs. You've got EC2 and EBS and S3. I want to say they added a few more things since that time. I thought Dynamo would run down here now, but could be misremembering that. So anyway, Outpost is just AWS hardware in your data center. Questions of any type? Okay. Let's do a little knowledge check then. Okay. What are some potential benefits for implementing a CloudFront distribution? What can that get us? So it looks like A and D are the commonly agreed upon, at least elements, although I saw a C in there as well. So the only problem with automatic redundancy for all application content is that you don't really control what gets copied out. It's all based on user requests. So you don't automatically push everything out to the users. It's only if a user has requested that material is it automatically copied out. So redundancy is not guaranteed because if a user hasn't requested it in that region, it won't be available to the user. So, and the global static IP addresses, that's part of Global Accelerator. So that's not part of it. Okay, so which of the following services offer some form of distributed denial of service protection, either at layer 7 or layer 4? Okay. Looks like there's agreement on D&E, shield and laugh. That makes sense. Good. Good. All right. This is a short one for this one. So we're going to roll into lab 6 and to configure a CloudFront distribution with an Amazon S3 origin. So this is going to allow you to get your hands on CloudFront. Here's the basic kind of like setup that we're looking at. So one, you're going to explore an existing CloudFront distribution. In other words, it's going to be set up for you. So you're already going to have CloudFront set up. Then you're going to create an Amazon S3 bucket. And then you're going to configure the bucket for public access, which is going to be fun because it shows you the steps you need to do in order to make an S3 bucket public, right? And then you're going to upload an object into the S3 bucket and then like test that you can publicly access it without CloudFront. And then you're going to add the bucket has an additional source or origin to your CloudFront distribution. And then you're going to secure the bucket with, what's called an OAI, which is an origin access identity. This is a thing that CloudFront creates that allows only CloudFront to access the S3 bucket, even though the bucket is public. So that way people can't get to the bucket directly. They have to go to CloudFront to get it, right? And then you're going to test direct access to S3, which should fail at that point in time. And then you're going to test access to the bucket using the CloudFront distribution. So you're going to run through a couple of tests. I think on the So there you're going to see all the different tasks, which of course are going to be laid out on your lab as well. So we're now on lab 6, which is up and running. So go ahead and click on Start Lab. Here are the various tasks down here. They do have a cross-region replication section down here. So they'll actually allow you to create what's called a CRR between one bucket in one region and a bucket in another region. I thought there was another optional. Hold on one second. I don't see it on the list. Nope, there isn't. It's just the one optional. So you're going to get started with task one. This lab, just like the other labs, is typically a 45-minute lab. Again, the same caveats that I mentioned before still apply. The only difference is that, you know, you're not waiting for anything that's gonna, you shouldn't require a lot of patience to like see things come through. This stuff all works pretty quickly. Okay. Might take a minute or two for the CloudFront to source from origin, but that's it. You won't be waiting 5 minutes for a message to show up. Okay. Any questions at all before we roll into lab 6?
Nope.
Okay. We'll go forth and conquer. It's about 11:15 right now. I'm going to check back in around noon. And then, you know, plus or minus 5 or 10 minutes there if people need extra time, and then we'll roll into backup and recovery. So go ahead and conquer lab 6 and let me know if you have any questions or considerations. Okay. Our last check-in question was basically, what do you work with? So, you know, most companies have a dedicated team that's responsible for receiving backups and managing the backups themselves. Every once in a while, you'll find like a cross-functional team that'll do DR. So I don't know if any of you have to deal with any of this, but we don't necessarily need to dive into it. But is anyone responsible, by the way, for all of it? Oh yeah, okay, yeah. Good to know. So the call to action here is really about, you know, disaster recovery, disaster planning, right? And, you know, I'm a big fan of, I don't think that backups matter as much as restores matter. So I'm a big fan of, I think backups are just one step in the process. I think if you haven't done a restore on your services, those backups are useless. So I always tell people, like, when's the last time you did a restore? Not, I don't care about your backups. When's the last time you actually restored your service? Because otherwise, you have no idea whether those backups work. You have no idea whether your process for restoring even functions, and you do not know the path to get back to a restored service. So, you know, so AWS has very clear like services that can support the backup process. They also have a lot of services like infrastructure as code that can support the restore process, not necessarily the data, but at least the services, right? So, and AWS has really, like, recently they bought a company that does disaster recovery that's also used, by the way, for like data center migration. So they've got some interesting offerings. A lot of this is covered in more depth with the advanced architecting class. And so you won't really find it like in the security engineering class or any of those pieces. There's some mention around backups, but mainly it's in the the DevOps engineering class and the solutions architecture professional classes. So the questions that are related to this are, it's like, how do we prepare for potential disaster event or data loss? So either service loss or data loss, it doesn't matter really at what scale. What do we do when we talk about, you know, recovery, downtime, and data loss? Like, what is our process for restoration? What do we need to think about? And then tools and services that AWS has for backup and recovery. And there's some general kind of architectural design patterns, right, that are generally considered, right, when we look at this. So DR, AWS backup, and then recovery strategies. So what's our recovery time objective, right? Which, you know, really when you talk about, you know, RTO and RPO, you know, you're talking about how much time is it going to take for us to restore this service? How can we get back to a working order? And how much data can we lose? So how frequently do we need to be taking backups over what time frame, right? So I have, you know, in the span of my 25-year career, I've seen a lot more DR fail than I have succeed. Now, recently there's been more success, but in the first like 15 or 20 years that I was even involved in these projects, they would more frequently than not just fail. Now with automation on the rise, with infrastructure as code on the rise, with our understanding of how precious our data is, both the intellectual property that sits in Git repos and the actual like user behavior, consumer data, that kind of data, you know, we're now knowing that this is far more valuable than we realize, and losing it is going to be catastrophic. You know, the items listed here as far as a lack of testing, not really, and not, it doesn't matter if the recovery path is complex. What matters is whether it is known and or automated. Those are the two things that really need to happen, is that they need to be known, which either means documented or in code, and they need to be automated if possible, especially if the path is complex. And then of course, not having sufficient resources. That early days, I would see a lot of failures because people were trying to shoehorn in big systems into smaller systems, and that just honestly just wasn't going to work. And then of course, people would have these documented processes that were different from production that they would use for disaster recovery. That doesn't make any sense. Every change you make in production live needs to be replicated to your DR plan. So if there's no method to do that, then the plan's not going to work. So, and you know, every single change that happens has to be mirrored in. So probably preaching to the choir there. So, you know, production systems and mission critical systems usually come with implicit, like invisible objectives in terms of like uptime, which is unfortunate because it's actually better to have them declared. You know, when I usually do a design and we're going to go forward with the project, I usually am upfront about, all right, this thing's going to be down, you know, 10 hours out of the year, maybe at one time. Do you care? People are usually horrified and they're like, okay, no, this thing can only be down for a max of 4 hours. Excellent. That's going to cost you $250,000. They're like, you know what? It can be down 8 hours. You know, because there's obviously a price tag associated with most of this. Now, when you're offering infrastructure as a service, you can usually offer some base minimum of uptime across all your components. So especially when you're doing like platform services, it's easier to do that. So things like high availability, fault tolerance can just be baked into the equation of what you are constructing for that platform. AWS is no different. AWS, you know, allows you to make design choices, configuration choices that control whether you've got, you know, 4 nines or 5 nines, right? Now, AWS is notorious for avoiding any comment about what their actual availability is, as an example. But when it comes to like infrastructure, like availability zones and regions and kind of more raw infrastructure like EC2 and EBS, they are actually expressive around that. So, you know, so when you look at this, you have to plan for component failover, which is a little less of a concern with AWS because they'll take care of that for you. But then what happens if it causes the instance to fail? What happens if the availability zone fails? What happens if the region fails? What happens if something global like DNS goes down? What do you do then? Know that, you know, some of the larger companies that I work with will actually have 2 DNS providers, one inside of AWS and one out, simply for that reason, even if they are all in to AWS, because that's the one service that if it goes down, globally, everybody's down, right? Just in terms of, you know, the service availability within the cloud provider. So things like, you know, that you have to think about. Now with RPO, we're talking about how much data can I lose, basically, right? Disaster occurs at 1 o'clock. The RPO is 12. Then the system should recover all the data that was in the system before 1 o'clock, right? So data loss at most will span, you know, 12 hours, right? Between that 1 p.m. and 12 a.m. time frame. Now, RTO says, how long is it going to take for us to restore this application? How long can it be unavailable, right? Just know that whoever is the lowest is going to drive your requirements higher. If both of them, you know, are really stringent, then you're going to have near real time, if not real time, like SLAs are going to say you cannot be down. It needs to be 100% uptime, right? So even if your RTO, by the way, is like, look, you can take 12 hours to restore the service, but your recovery point objective is we're going to back up data every hour. We can only withstand the loss of 1 hour's worth of data. That might actually drive your requirements down, but typically RTO dominates in the equation. Like how long do I have to restore the service in the event that it's down? Usually RTO dominates, but just know that they can both drive requirements pretty high. Now, they will ask you, by the way, what the difference is between RTO and RPO. Sometimes they ask questions about that, but mainly what they're going to ask you is, what are the design patterns that you're going to use for existing situations? They might ask you, by the way, if you want to, if I want to back up S3, what do I use? Well, you can use cross-region replication. What about Glacier? Well, you're going to replicate that into another vault if you want to. What about EBS? Well, EBS can be snapshotted, and the snapshots can be replicated to another system if you need to. They're not going to ask you about Snowball, and they're not going to ask you about DataSync. DataSync, by the way, can be used to send information between two EFS copies, but most people don't use Snowball for backups. So, you can also, when you create custom AMIs and custom images, you can also make sure that they are automatically copied to a new region. So most of the tools that you use to create these images can actually push them to 2 registries or 2 locations at the same time. So you could have a primary and then a secondary location. And so every time you update your images, whether they're virtual machine images or Docker container images, push them out into 2 locations. So that way you have access to a backup. And then, understanding failover, both cross-region failover and cross-physical location failover, because you might have VPN as a backup for your direct connect connection if direct connect goes down. You might use global accelerator to point to multiple ELBs. And Route 53 is supposed to be 100%, but you might have a second DNS provider just to make sure. Other items we've covered, like DynamoDB, you do not need to worry about DynamoDB, because if the region fails, DynamoDB is just going to go down. But you don't have to worry about if an AZ fails, because DynamoDB doesn't operate on an AZ level, right? And by the way, you can roll, if there's a corruption, DynamoDB will allow you to use point-in-time recovery for continuous backup for up to 35 days. So you can roll the table back to a specific point in time. You can also initiate your own backups, which it is recommended that either use AWS backup to initiate backups or have your own system that is working. And again, just as a statement, restore those backups on a regular basis, a minimum of once a month, preferably once a week. It just needs to restore the backup, and you can write an automated test to just go see if the data is there. I mean, that could all be done programmatically without you even having to touch it. It sends you an email and says, hey, by the way, click this link if you want to touch the database. It's going to stay up for 30 minutes. Otherwise, it's going to get deleted. We tested backups.
Is this also true for the serverless databases?
What do you mean? What is true?
Is the backup, the automatic backup and the rollback feature available even in the serverless DynamoDB?
Yeah, no, this is DynamoDB is serverless, so yeah, it's definitely available. Yeah, RDS is the one that has the RDBMSs in it. So I'm just talking about the bottom one, just talking about DynamoDB. RDS operates like a standard relational database management system, so it does not have continuous point in time backups. Only the serverless one on the bottom does. The one at the top, you have to do basically snapshots. Now, RDS will actually do automatic snapshots for you up to I think also 35 days, if I remember correctly. And you can actually restore the backups if you want to. I wouldn't say they're point in time, because DynamoDB does continuous backups, so it can restore at any point along the time frame. RDS can only restore back to the latest backup. So think of it more like checkpoints, whereas DynamoDB can roll continuously across the 35-day time frame.
Got it.
Yeah. Now RDS will take automated backups, at once a day for up to 35 days. You can also initiate manual backups of RDS. I cannot emphasize this enough. If you're using RDS, you must initiate your own manual backups. every once in a while, once a month, once a week, again, whatever your RTO is. I know that you have automated backups, but just to say this, if someone accidentally deletes that box, all of your automated backups are going to get deleted as well. Most people don't know that, but if someone deletes that box, your backups are gone. If you've taken manual backups intermittently, even somewhere in there, those manual backups will be retained. So just be careful with RDS. I've had clients shoot themselves in the foot by, someone went and deleted the database thinking it was non-production and it was production, and they lost all their backups for the database because all they did was take automated backups. So just word of note. AWS backup, by the way, as a service will help you with that by automating your quote unquote manual backups that are not part of your original 35 days of automated backups. So just know that these two services have better backup capabilities than, say, Keystore, DocumentDB, Neptune. Those services have not yet evolved to this level yet. They've got some backup capability, but they're not as sophisticated as these two services because these have been around for over 10 years. So just know that you're going to have to do more manual management of backups if you're using any of the other backup services. Redshift is probably the other exception. Redshift has good backups. Anything that you build in AWS, ideally, you build with infrastructure as code. So whether that's Terraform or CloudFormation or even scripts, as long as they're repeatable and they're versioned, I'm not going to knock a PowerShell script or a Bash script that gets the job done. But every time you make a change to that system, I would, recommend that you change it in the code and then execute the code instead of changing it in the console. Because if you change it in the console, you will never know whether or not you can actually recreate it because you didn't create it through your like DR process, your backup process. You created it through the console. So general rule of thumb is that try to make your infrastructure as programmatically created as possible, and then you can recreate it easily. I actually had another company where they lost a good portion of their non-production environment, and it was deleted. And when we came in, everybody was kind of freaking out. And I already knew the status of our restore capability. One of my guys recreated the entire non-production environment, created a whole new copy with production copy database, Artifactory, CI/CD pipelines, the whole 9 yards. It took him about an hour to restore the whole thing, maybe a little less actually. And then they went in and validated it, and they were like, wow. And they were like, yeah, because this whole thing is done programmatically. So just an emphasis there. Backup is the tool. AWS backup is the tool that I was talking about, right? It basically allows you to centralize your backup strategy in AWS, so you can actually see what's working, what's not. And so it's really just a fully managed backup service. It does work with organizations, so it will work cross account. And it's going to include everything that's listed here. EC2. I do not remember yet if it has been expanded to include ECS and EKS. I think that's in the works, but it does all the file systems, as you can see here, including EBS. It does the two major flavors of database. Ignore Aurora. That's just a flavor of RDS. So it does RDS and DynamoDB. It does a bunch of other services as well, storage gateways there. But there are other services that it actually does because they keep adding new services all the time. So, to say this is that you can actually see the storage gateway sitting right in the center there. You can actually insert a storage gateway onto your data center, have it act like either a disk, provider or a tape provider, and it will automatically back up all your stuff out to the cloud. Now, the other thing I want to tell you, I know this is going to sound so strange, but take a backup out of the cloud. I know it's gonna sound weird, but like if you can, at least like a point in time check, like a once a month or something, get it out of the cloud. You know, it doesn't even matter if it's like backed up to a set of USB drives somewhere. That's not preferred, but or even use another provider. Like it doesn't even have to be one of the hyperscale providers somewhere, but in your data center somewhere, you know, be sure it's the rule of three, right? You get a primary active backup that's probably quick to access. You got another one that's archived out, and you've got another one that is off the system, right? Like when I run backups to my house, I got an active backup, I got a colder backup, and I have another backup that is out of my house, right? So just remember that kind of rule of three is that while Amazon has tools to kind of like, you know, take your data and put it all in the cloud, and I know it costs money to take these backups out of cloud, just, you know, consider the use case of like what happens if like all that gets corrupted or something happens. You know, just consider like keeping some kind of backup copy out of the cloud as well. The rest of this, as far as like how you do backups, you know, is it encrypted? Is it not encrypted? You know, how do you do data protection? Is there scrubbing that needs to happen? How do you report against it and compliance? You know, costing, those kind of things. For cloud backups, AWS backup is the service that they use to solve this, right? So it will enforce backup encryption, enforce access policies. You get all kinds of API and log-driven reports. It will comply with everything from ISO 27001 to 27017 to PCI DSS, all the stuff, right? I say all the stuff. It's like 5 or 6 that it'll be compliant with. And there's no extra orchestration here. This natively integrates with AWS. So, and you know, set up a schedule and do incrementals and whatever fulls, whatever you want to set up there, right? It basically lets you meet your whatever regulations or business goals you have for backups. Now, backups is interesting is because you're going to create a backup plan that orchestrates each of the operations on like a specific policy on a specific surface, right? And the vault, excuse me, the vault is where the backups are actually stored. And the vault is where you control access because vaults basically are encrypted. And so you can create multiple backup vaults. You can put it in a standard, you know, default backup. It doesn't really matter. It just depends on what your policies are. And so here, you know, you create a backup plan, you define the frequency, the timing, what roles are going to be used to access these different services. You can define a lifecycle policy. So you can move it from like hotter access to colder access, which I highly recommend. And then you figure out which resources are going to be part of this backup plan based on either specific tags that you've put on the resources, like everything that says production, go. I want it backed up. Or you could say, look, everything that's in project A, project B, project C, and it says production, I want those backed up. So you can be specific if you've got a decent tagging strategy. See Exhibit A for the conversation I had 2 days ago about people's ability to tag their environments. You might then fall back to things like Amazon resource names where you're like, look, this DynamoDB table is production, just back it up, right? And then from there, you just need consistent reporting that the backups are happening. And then, you know, I would add a 5th step here, which is you need to create a system to test restore your backups, because these backups are useless if they're not restored, because you have no idea whether they're good or not. So add a step 5 here, restore your backups on a regular basis. I don't care if it's once a month, maybe once a quarter, once a month would be preferred. But restore your data and make sure it's legit. And again, you can write a test for that. Restore it back to an EBS volume, mount the EBS volume, check to see that the data is there, let it go when you're done. So it didn't have to be a long, involved process. You just need to come up with the test framework for it. So that covers backup and then just general concepts around DR. What about recovery strategies? Well, this is where Amazon gets really specific about the like 4 major design patterns they want you to think about. And they're built for different kind of RTOs and RPOs. So first is I don't have anything but my data backed up, right? That's what this example is, right? In this particular case, you've got a backup going to a remote location. Maybe it's going to a backup region. And the only thing that's there is your backups. That's it. So you're going to recreate everything from scratch, preferably using infrastructure as code, and then you're going to restore your backup. That's it. All right, that's all you're going to do. Now, that's one way to do it. It's the cheapest way to do it, but depending on the size of the backup, it's going to take you hours, if not days, to do this, right? Now, in the second example, we actually have our data stores online. So I've got a primary production data store on the left. I've got a recovery data store on the right. The only thing that they're doing is data replication. Now, in this case, the production environment is actually on premise, but you could do this all in cloud if you wanted to as well. It's very cost effective. The only thing you're paying for is the additional database on the right-hand side, but you've got stopped instances or instances that you know how to create really quickly programmatically on the recovery side of things. So in the event that the left-hand side fails, you start up the web servers, you flip the database into primary mode, and then you roll DNS over. Now that could take a second. That could take tens of minutes, actually. It could take hours, but preferably tens of minutes. Like, let's say 10 minutes, 20 minutes at most, right? The web servers, you flip the database over, maybe simultaneously you start the web servers. You've already, flipped the DNS switch, but you're waiting for the caches to expire on all the systems. So, worst case scenario, it takes you 15 minutes to get this whole thing rolled over. Probably more like 5 before you start seeing some relief, right? This is a pilot light. This is also sometimes known as a warm. Is it a warm? No, just a pilot light. It's just a standby. So the next one, compared to a full backup and restore and compared to a pilot light, is basically what they call it's almost like a warm standby, right? You got the database. You've actually got servers. You got web servers. You got app servers. You got pieces of your infrastructure running. But what's happening is that they are low capacity, which means that maybe they're only taking 10% of the traffic. Maybe they're only taking 20% of the traffic. And you can do that with DNS easily. Put some weighting on that there, right? Now, the only problem I see with this whole thing, I'm just going to mention this particular diagram. Does anyone see an issue with this diagram as far as the architecture? My only issue is, who is this app server talking to? Probably not talking to this guy if it's active passive. It's probably having to go all the way back to the system. But just say this is that is probably easily mitigated either by putting a caching server here, or some of the standbys can be put into like a read mode if you want to. But writes are still going to be going back to the primary. So this is a little bit of a weird architecture because your app server, which is in production, is going to be talking back to the data center. So again, you might have a pretty fast network connection for that. So this is a fully working low capacity standby, sometimes called a warm standby. And so if the system goes down, the database has to be elevated to primary. You've already got auto scaling around the servers in the recovery area. So then DNS needs to be changed. And you might want to go ahead and pre-scale up your auto scaling group if you know it's not good enough, right? This is for when recovery needs to happen in minutes, like guaranteed minutes, not tens of minutes, not hours, minutes, right? So this is when it has your RTO is minutes. And then last but not least is like, this is when it either needs to be seconds or, you know, it can be like up to a minute, but typically is like near real time as possible. This is like a hot standby. This is active, active. So both may be taking equal traffic. And then the event that the, you know, the secondary goes down, what ends up happening, sorry, the primary goes down, the secondary has to scale to take all the traffic. My only issue with this is that I don't know that you could get away with this guy being a secondary. I think that had to be some kind of primary, like multi-master kind of database, like multi-primary, multi-active databases. So this is when you need the like recovery to be really in like, you know, really in like seconds. So if you look at this, the backup and restore, the restore process is really for, it's like, it supports hours. Pilot light is for tens of minutes, warm standby is for minutes, and the active standby, the hot multi-site standby is really for seconds or real time, right? Because it may not be real time. You might see a blip for a second, right? Notice that the money goes up because you're going to have active resources. But if I can just say this, you know, oddly enough, the hot multi-site standby is actually cost effective because you're running working infrastructure in 2 locations. So 100% of the load is split across, you know, those systems. This is the same also for a warm standby as well. Pilot light's the only one where the backend infrastructure is not being used. And of course, this one doesn't cost you anything extra. So there's no issue there. They are going to provide a scenario that says the RTO needs to be real time. And you're going to need to know that you need to use a hot multi-site standby or active standby. They're going to say, you know, do you understand this? They're going to say, look, the RTO or RPO is tens of minutes. And so you need to know that they're going to use pilot light. Because whoever's the lowest, right? Especially if the RTO is typically the dictator, then it's going to determine whether or not you can do minutes, real time, tens of minutes, or hours, right? Questions about that? Okay. Now, we have to make one honorable mention because I've already said it, right? Amazon bought a company called Cloud Endure a while back, and they have recently renamed it to the Elastic Disaster Recovery Service. This does a block by block copy of your on-premise machines, converts them if like there needs to be a change due to licensing or whatnot, converts the operating system, and then places it into these low-cost EC2 instances and EBS volumes that are literally just there taking traffic. When you need to cut over, what happens is that it will then stop the replication, reboot the systems with new sizes, staging becomes production, and it will then size the boxes for what is appropriate based on what it saw over in the data center. And so this will automatically convert your servers to boot on AWS. So it'll stick in the AWS drivers. It'll stick in Cloud Init. If it's Windows, it'll stick in, what do they call that? Cloud something. It'll stick that in as well. So whatever you need to get those servers to boot, it will insert it in translation. So just mentioning this because it's a pretty cool product, especially if you need to like en masse get an entire data center migrated into AWS, or if you just want to use it, you know, for DR. So just know that it's there. I used Cloud Endure before AWS bought them, and they were good then, and this was like 3 or 4 years ago. So since AWS got a hold of them, the integration's gotten even better. Okay. Last little bit. Which DR model offers an RTO in minutes at the lowest cost? Now, let's be clear. It is tens of minutes, right? But it is minutes, right? You can make an argument for the fully working low capacity standby as well, but it is tens of minutes at the lowest cost. Okay. Which metrics define how often data must be backed up? All right, so most people put A and B, but be careful. RTO has more to do with service restoration, right? Not to do with backups as much. But if your data never changes, then you don't have to back it up, right? You can back it up once, right? So the data change rate actually is the other variable. I know they kind of tricked you because we've been talking about RTOs and RPOs, right? Which of the following are highly available resources by default? Meaning regionally or globally highly available. Which of these are highly available by default across a region or globally? So Route 53 is globally available, highly available because it's got 100% SLA, right? ELBs run across an entire region, right? Because they're virtual devices that literally stick network cards in all the availability zones. So they're highly available. And NAT gateway, by the way, is tied to the availability zone it's in. They do not span availability zones. And direct connect is a single connection. So it is not highly available by default. That wire gets cut, you're done. Okay. Which of the following are features of AWS backup? And please don't answer B. Just as we well saw, it does not work across every service. Mike, I could have expected that from you. Okay. Well, we're going to stick with Connor's answer, actually. So encrypted backup. So that definitely happens, right? So we all agreed on that. We all agreed that it works across multiple services, right? And I told you B wasn't the answer. But then, designed for cloud native workloads, continuous data replication, and automated machine conversion. So the continuous data replication and automated machine conversion, that's the tool we were just talking about, the data center replication tool, like the Cloud Endure stuff, right? Because backup doesn't do continuous data replication, right? That's only for systems that are trying to either do migration or point in time recovery, which backups doesn't do that, right? Backups takes a snapshot and is one and done. And then automated machine conversion, that's also the Cloud Endure thing. It's the one that's doing the translation of inserting drivers and whatnot into the operating system as it's copied up to cloud. That's not AWS backup either. But since it is a cloud native backup service, it is designed for cloud native workloads. Okay. What is the best way to make an existing RDS database instance highly available and minimize your RTO? What's the best way? So high availability typically doesn't follow the rules of like disaster recovery, which would kind of fit more into that disaster recovery level. A read replica in another region in the same region might work to a certain degree, but it's not going to automatically like fail over. If you do B, it will automatically fail over to that instance. It is going to be the best way from Amazon's perspective to minimize your RTO is to have an automated process that just makes it happen. So a read replica has too much operational overhead compared to B, and A is more about DR than it is about high availability. Okay, so B is the answer. Okay, we are officially done with all the lecture material. Oh, and look at the timing. It is 12:57. Here's what's going to happen next. When you come back, I'm going to torture, test you with some more questions on just 2 sections. So there's just 2 sections of questions we're going to do. We're going to do that for about 30, 45 minutes. And then I'm going to post up the review of the class. So you can talk about how rude, crude, and socially unacceptable I was. And then actually, I'm going to do that afterwards. I'm actually going to talk about the student portal. So the student portal that you all have out here, we're going to talk about this. We're going to talk about training. I'm going to record it in a separate session so you can have it all recorded as a separate video. And we're going to talk about next steps for where you go from here. Some recommended study plans that we have that are out here as well. We're going to reaffirm access to the supplemental labs and all that to make sure that you're very clear, test and training wise, what you do after this course. And then after all that's recorded, I'll give you the evaluation then, and then we're going to roll into the capstone lab, which is the last kind of like meta lab, Uber lab that you do for the course. And once you're done with that, you can actually leave for the day. But we're going to start that around 2:30, 3 o'clock, and you'll have obviously until 5:30 to get that, complete that. Okay. Any questions about what we're doing next? Okay. Well, it's 12:59 right now, Eastern time. So we're going to come back in about an hour and 61 minutes, and we'll pick up the remainder of the training and whatnot. Okay. So we'll see you in about 60 minutes. Enjoy your lunch. Okay. So we have a web app using CloudFront to distribute their images, videos, and other static content in their S3 bucket to users around the world. The company has recently introduced a new member-only access to some of its high-quality media files. There's a requirement to provide access to multiple private media files only to their paying subscribers, and they don't want to change their current URLs. They don't want to change anything about the URLs at all. So this does require a little bit of meta information about CloudFront. And to say this, there's 2 ways. Well, there's actually 3 ways. There's 3 ways to provide encryption or control over like S3 buckets or URL access for CloudFront. You can use an OIA, which isolates the bucket to only CloudFront. You can use pre-signed URLs, or you can use what they call signed cookies. So based on that information, you don't want to change the URL. What do you think might be possible here? Good. Yeah, signed cookies. Yeah, I think that's the most likely answer. So if you use, they used to call pre-signed, I don't know if they switched it to signed, but they're like pre-signed, like they're already authorized. The URL already has authorization information inside of it. If you use either pre-signed URLs or pre-signed cookies, then obviously, if you use pre-signed URLs, you're gonna have to change the URL because you're gonna get a new URL for access, right? If you use signed cookies, though, the information is actually set in the cookie header, and so the authorization information. So therefore, you can get access to the thing in question. So this gives a very clear list of the different requirements, right? Because like, for example, signed cookies aren't supported for any video distribution. So only for any other kind of access or asset, right? And then of course, obviously, we're assuming the client supports cookies, which, you know, there might be custom clients that don't. So, okay. For this one, we've got a travel photo website, sharing website that's using S3 to serve high quality photos to visitors. After a few days, you found out that there are some other travel websites linking and using your photos. You feel like you're losing financially as a result in your business. What can you do to actually like mitigate this issue? There's actually another way that's not listed here. Anyone ever use CORS on a website, cross origin resource sharing? So S3 does support CORS. That's actually the most common answer that I see for this question in the actual exam, is to actually turn on CORS, cross origin resource sharing, which will limit people from downloading against S3 unless it comes from a certain domain. So if someone tries to click a URL and that domain tries to download the photos against that URL, it won't work. So in this particular case, since CORS is not an option, let's see. See some A's and some B's, just choose the first one. So in this case, you would actually use pre-signed URLs or pre-signed cookies, right? To make that work. Adding a CloudFront distribution, to your photos, that alone isn't going to help. It's just going to put a content delivery network. WorkDocs is like Google Drive, so that would be weird, honestly. And then block the IP address of the offending websites using NACL. Well, that won't work because S3 sits out of VPC, right? NACLs are VPC network firewalls. So here's the complete flow. So a user's going to request a file. There's a call against S3. What will then happen is that the app server is actually going to send, since it's being done on behalf of the app server is going to send the pre-signed URL back to the user, who's then going to use that URL to download the file, right? So note that somebody has to send the pre-signed URL back to the user for it to work. That could be, by the way, client-side JavaScript as well. It doesn't have to be like there's an app server right in there to make this step 2 API call. You could just do it from the browser. Okay. Number 3, I don't know if we're going to do all of these. No, we won't do all of them. Company has a global news website hosted in a fleet of EC2 instances. Lately, the load on the website has increased, which has resulted in slower response time for the site visitors. This impacts revenue as some readers tend to leave the site if it doesn't load after 10 seconds. Boy, is that true. Which of the below services in AWS can be used to solve this particular problem? What we're trying to do here is that we're trying to reduce the slower response time for site visitors, right? Because it's a global news site. So they want it to load as fast as possible. Now, ostensibly, the closer you move the file they're trying to retrieve to the user, the faster it is. So physics still applies. So I noticed that it was like C and D, I think was the predominant option, D, CD, CD, right? So let's check this out. So in this particular case, what's happening is that they are basically moving things closer to the user. Now, I gotta tell you, I probably would have gotten this one wrong. So just want to be frank about it, is that I would have thought that this would have been a better option, even though it is more costly, right? I don't know that there's no mention here about a website with, there's no mention of a database. Now, what they're saying is that, well, let's use, you know, for the website's in-memory data store or cache, let's use Elasticache. I mean, I guess that could increase response times. In other words, it would decrease load on the web servers. But there's some squishiness with the question that doesn't necessarily point to this as being like the absolute answer. Because remember, it said, which of the services below can be used to solve the problem? It didn't say which is the most cost effective. It didn't say which one is it didn't say what's the best service. It just said technically, which of these below could be used to solve the problem. So I got to tell you, I probably would have gotten this one wrong because I would have put A and D, because I would not have guessed that Elasticache for the website's in-memory data store or cache would solve anything, because Elasticache mainly is used for either session storing information or to store like carts or to cache backend database queries. I wouldn't have thought that it would actually cause websites to load faster. So I don't know about that one. I'm going to write that off to a squishy question, frankly. Like in the example, obviously they list CloudFront. That makes sense. But this one, I don't know about that. Now this, and it would be true that like they're doing, like replicating the website in different regions would be costly, but they make no statements about cost effectiveness. And compared to this, again, I don't know what that's actually going to do, frankly. I can't think of a single web services based architecture where if it's not doing sessions caching or like shopping cart caching, where that would actually improve things. So we know CloudFront's one of the answers, so we'll move past that one. All right, one more. Let you read this one. All right. I see a bunch of C's there. Obviously, you're picking up on it. Something obviously you just built yourselves, right? Is creating an origin access identity for CloudFront, right? That makes sense. Yeah, and just say this, you're gonna say A and C. I think that's a step in one of them, but I don't know that that alone would get it there. But I mean, if there was pick two, that might be the next thing, right? Because this wouldn't work.
Right, for a second, so, but C was the one I think I was kind of going for.
Yeah. I love this. A web app WAF to block any public access to S3 and attach it to a CloudFront distribution. That would be tough. That would be really tough. Anyway, C is obviously clearly the answer because you need an OAI for that. Okay. Let's do a little bit on Lambda. Okay. So companies building an internal app that serves as a repo for images uploaded by a couple of users. Whenever a user uploads an image, it would be sent to Kinesis data streams for processing before it hits the S3 bucket. If the upload was successful, the application will return a prompt informing the user the operation was successful. The entire processing set takes about 5 minutes to finish. Which of the following options will allow you to asynchronously process the request to the application from the upload request to Kinesis S3 and return a reply, all in the most effective manner? Like, what's the best service that you could use to do this? Okay. I see a lot of C's there. I know that this may sound weird, but I don't have the answers to these questions like memorized or anything. So I'm reevaluating them every time I see them. I got to tell you, when I read the question, I was like, why is Kinesis data streams even in there to begin with? So I was kind of relieved when I got to the answer, and it was like one of the options was take Kinesis data streams out of there, because quite frankly, that's not what it's used for. And then replace it with an Amazon SQSQ. Because if we're talking about asynchronous storage of some kind of message, and it can be done in under 15 minutes, which is why they told us the entire processing time typically takes about 5 minutes, which means even if we're squishy and add plus or minus 5 minutes, at most we're looking at a 10-minute execution, right? A Lambda function will work fine there. So then we're not paying for servers, and we're not paying for Kinesis data streams, which is a 24/7 charge. So you don't, with an SQSQ, you only get charged for all the API calls that you make against it. So C makes sense. Using a combination of SQS to queue the requests and then process them using on-demand EC2 instances, A is actually a valid answer. It's not the most cost effective. So in the end of the question, it says, what's the most cost effective? And then you could also use the combination of Lambda and step functions to orchestrate service components and asynchronously process the requests, but you're still using data streams, and you haven't really addressed the issue of where are these files going to land that you're going to process them and then get them into the S3 bucket. And then SNS will not store anything. If you send it to SNS, it's going to shoot it out somewhere else. So it will not, if you hit SNS with 100,000 messages, it's going to send 100,000 messages right off the bat. So that's not going to be asynchronous. That's going to be synchronous because it's going to kick everything off in real time, which could overwhelm the backend system, even if it's Lambda. Lambda out of the gate only allows 1,000 concurrent executions. So probably best in that particular case, because you're also using on-demand instances there as well, which is more expensive. Probably best in that particular case to just use an SQSQ with Lambda. Okay. All right, let's do a few more. Let you read this one. Okay. I've got, it looks like C is definitely agreed upon. Not D, okay. And then I've got an A and an E. All right, well, I only get 2. Right? You know what? Just for giggles, let's check and see what it says. Okay. All right, so here's the thought. So you need the most cost-effective solution that can improve your app's performance. And what's the problem? The problem is that users are saying it's taking a long time to log into their website. The second problem is there are occasions where they're getting a 504, which is a backend problem, correct? So we got 2 problems. 1, the logins are taking too long, and 2, we're getting a 504, which something's wrong with the backend. We're not sure what. So the first problem we want to solve is, how do we solve in the most cost-effective way the login problem? Well, here's the only way to do that. You got to bring the login logic. You got to bring that logic closer to the user, or slim the logic down, whichever. Now, this is a little known fact, but Lambda can actually run functions at the edge, not in the regional data center, but closer to where the user's at. So you could actually use that to log in by pushing the login mechanism closer to the user. So that solves the first problem, and that's super cost effective because it's it's Lambda. The second problem is that users are occasionally getting 504s. Well, that's because there's no fallback infrastructure. So what you can do is you can set up an origin failover with 2 origins. Specify one as the primary and the other is the secondary, which CloudFront automatically switches to when the original origin fails. That could be another application entry point into the authentication logic. It could be another instance of the Lambda function if the Lambda function is already being used, or whatever the application is. But you might like either duplicate the application or just point to another server, another entry point into your application. And so if one fails, it's just going to go over to the next one. Right? So that way, if the first one chokes out and throws a 504, it's going to fail back to the second one and say, hey, can you log in? Now, if the second one fails, you can't avoid that. But it sounds like they're looking to set up some redundancy here. Now, if you use multiple and geographically dispersed VPCs and set up like multiple copies of your app, that's going to be relatively expensive. Deploying the application in multiple regions, that's going to be relatively expensive. And if you do this, by the way, that statement does not make sense, actually. If you specify the longest practical value for increasing your hit cache ratio, the login is a dynamic function. It's not a static function. That's only going to help you with static assets. So when you need to do something dynamic like login, controlling cache control max age is not going to make a difference. It's a dynamic execution. Is that clear about the two problems we're trying to solve? Is that any questions around that?
So I guess one of the key things on the second one is like the occasional failure. I guess I kind of read it as it was just failing straight up. So like the occasional failure, meaning it needs something to fail back to. Makes sense, I guess.
Yeah, it's flaky, right? Now, should we troubleshoot why it's flaky? Probably. Are we slackers? We're not going to get into the root cause as to why this thing doesn't show up every once in a while. It may also, by the way, be the internet, right? And that's hard to troubleshoot. So adding in a secondary entry point could help. It might be interesting also, just to say this, Connor, to insert some code into the front end, like web page, like at the very beginning, some kind of like tracing or tracking code to see if the user is experiencing some kind of latency that we don't have control over, right? That would be something you could do with CloudWatch, actually. But unfortunately, that wasn't one of the answers. Okay. Well, let's read the next one. All right. So I got a bunch of votes for A and E. I got to tell you, this is one where I had to, like, you have to think about it. It's like, do I know what all the destinations are for S3? But then of course you look and maybe you did. I didn't. I was like, I know that's not on there. I know Kinesis isn't on there. And I don't even know if we still use the simple workflow service, but these two I know are on there. So I'm glad they didn't ask anything super fringy because, it's like a long list of what can be event notified off of S3. So I wonder if they have that list down here. SNS, SQS, Lambda. I'm pretty sure actually supports more than that, actually. It's not just those three. Regardless, seems like you all had it as well. Sorry, now I gotta take a look. Huh, well, maybe it is just those three. I don't know about that. Yeah, Event Bridge is on here as well. Okay, maybe that was the one that I was thinking. Is that Event Bridge was on here as well. CloudWatch events. All right. All right, last one. This one I'll read. So a company is using a VPC that has a CIDR block of 10.31.0.0/27, right? So it's connected to an on-premise data center. There's a requirement to create a Lambda function that will process massive amounts of cryptocurrency transactions every minute and then store the results to EFS. After setting up the serverless architecture and connecting the Lambda function to the VPC, the SA noticed an increase in invocation errors with EC2 error types such as EC2 throttle exception at certain times of the day. What are the following, like, are the possible causes of the issue? So first of all, let me ask you this. How many usable IP addresses are you going to get off a /27? If a /24 gives you 256, a /25 gives you 128, a /26 gives you 64, you're going to get 32 minus 5, right? So 2 for the network, for the broadcast and this network declaration, and 3 for Amazon. So 32 minus 5, so you're going to end up with 27, right, usable IP addresses. Kind of interesting thing there. And they're processing a massive amount of cryptocurrency transactions every minute. Let's assume it's more than 27, because every time you launch a Lambda transaction, a Lambda function, and you've attached it to the VPC, that means you've given the Lambda function an IP address. So let's check and see, because maybe this is completely wrong, but the thinking there makes total sense, right? I gotta tell you, I don't know that I've ever seen this question ever. This is the first time I've ever seen them where they offer a question where they've actually attached a Lambda function into a VPC. I obviously knew you could do that. I've not done it myself, but I've never seen a question with this in there. So it's interesting, because that's going to require you to basically bake out a little bit of the math here and to know that you're going to eat an IP address every time you run that Lambda function. So it's a little deep into the meta here. I wouldn't be surprised if this was a throwaway question, because it's more of a professional level question. But regardless, you guys did excellent, right? Kind of reasoning that out. Also, I have to say that when I read through the answers, I was like, doesn't this actually say the same thing as this? I realized that these were talking about multiple ACs, right? But this is the entire VPC. So good. Questions about any of that? Okay. So let's do this. I'm going to stop the recording.